All right, so this video is on substitution and elimination methods. It's two more ways to solve a system of equations. So we already learned how to solve a system by graphing. Now we're going to do substitution and elimination. Go ahead and pre-rate yourself on how you feel about these two methods. You learned them in the class that you took previous to this, but that was some time ago. So do you remember? All right, go ahead and start by pausing the video and doing the warm-up. All right, let's see how you did. Your y-intercept's 7 and your slope is 1. So I'm going to graph that line. Remember, you're putting all the points that are on the line that are on the graph paper and then drawing a line through it, putting arrows on the end. Because if the lines intersect, it's going to be one of those points that's on the graph paper. Okay, next one, I have y equals 2/3 x plus 2, y-intercept of 2, slope of 2/3. So up 2, right 3, and there's my intersection. I'm going to continue to go down 2 and left 3 and make my other points. It's really good practice to complete the problem. Okay, now I want my solution. There's one solution to this, and it's the intersection of those two lines. So the solution to this equation is 3, 4. The solution to this system is 3, 4. All right, so here it says we saw previously that we could solve a system of equations by graphing like we just did in the warm-up. We can also solve a system of equations algebraically by using the substitution method. So we're going to start with the substitution method. So here are your steps. Step number 1, if necessary, because sometimes it's not necessary, which in our case, it'll never be necessary. It'll already be done for you. Solve one equation for one variable. So I only use substitution if one of the equations is already solved for one variable. To avoid fractions, we're going to choose to solve for a variable but that has a coefficient of 1. So this first step is pretty much already done for you in everything that we're doing because I only use substitution if an equation's already solved for a variable and it has a coefficient of 1. I'll point that out right here and here. This equation's already solved for y and the coefficient's 1. This equation's already solved for x and the coefficient's 1. So like that's already going to be done for you. All right. Step number 2, you are going to substitute the resulting expression into the other equation. Once you do that, once you substitute that expression to the other equation, you're going to solve that equation for the variable that's in it. You're only going to have one variable now. Once you get that value, you're going to take that value and you're going to substitute it from step 3 into either equation that was that you started with. And then you're going to solve for the other variable. Finally, a very important part right here, which I'm going to highlight. Write the solution as an ordered pair. Okay, so you're going to write the solution as an ordered pair. X comma y. Let's write x comma y right next to that. X first, then y. Okay, so here are the examples. It says solve each system using substitution. So make sure you pay attention to the directions because sometimes it'll say use substitution, sometimes it'll say use eliminations, and sometimes it'll say whatever method you feel like. Okay? All right, we'll do these two together, and then I'll have you pause the video and try the next two on your own. All right, so you're going to look at both equations, and you're going to look at in each one and say, is either of the equations solved for a variable? This equation's already solved for y, and I know y is the exact same thing as x plus 2. So that means when I see a y, instead of writing a y, I can write an x plus 2. So in my first equation, I see a y, and instead of writing a y right there, I'm going to replace it with an x plus 2. So now I have, and I usually don't cross that out, but I want you to see what I was doing there. So I'm going to start writing this equation right here. I'm going to write x plus, and then instead of writing y, I'm going to write x plus 2. Then I'm going to finish off the equation, equals 6. See that? Now you're going to solve this. There's like terms that you need to combine right here. X and x is 2x, and then plus 2 equals 6. Subtract 2. You have 2x equals 4, and then divide both sides by 2. we have x equals 2. Now this is only part of your answer because if you remember to the warm-up here, it's an ordered pair where the two lines intersect, and we only found the x value so far. So we still need the y value. What I like to do is I like to start off by saying I know x is 2 and then leave a blank space for y, and now I'll solve for y. So I'm going to go to back to either one of my equations. I always like using this one that solve for y. So I'm going to do y equals, instead of writing x right here, I'm going to write 2 and then plus 2. Y is equal to 4. So now I have the point 2, 4. If I wanted to grade my own test, I could. All that I would have to do is if I got this 4 from this equation, check my answer in this equation. X plus y should be 6. Is 2 plus 4 6? It is. Now I graded mine, and I know I got 100% on it. That's what's great about this test. All right. Next one here. I look at both of my equations. I say to myself, in either equation, is there a variable to solve for? Yes. In the second equation, I know x is the same thing as negative 2y plus 6. That means when I see an x, instead of writing x, I can write this. And in my first equation, I see an x right there. So now I'm going to rewrite this equation. I'm going to write the 3. But then instead of writing x, I have to write negative 2y plus 6. So make sure you put it in parentheses because you need to distribute to that at some point. Then I'll continue writing the rest of this. So I have minus 4y equals 28. All right. I already said it, but you have to distribute that 3 to everything in the parentheses, to these two things here. So now I have negative 6y plus 18 minus 4y is equal to 28. Now I want to combine like terms. I have a negative 6y and a negative 4y, which is negative 10y, plus 18 equals 28. I'm going to subtract 18 from both sides.
Sorry, I couldn't hear what you said.
And I have negative 10y is equal to 10. Finally, I'll divide both sides by negative 10, and I have y is equal to negative 1. So now I have the y value, and I just need the x value. So I'm going to start to write my ordered pair. Remember, I found the y value is negative 1, and now I need the x value. So once again, I like going to this equation because it says what x is equal to already. So I'm going to say x is equal to negative 2 times, I know y is negative 1, so I'm going to plug that in, plus 6. So I have x is equal to 2 plus 6, x is equal to 8. So there's my solution, 8, negative 1. Once again, if I wanted to check it, I plugged it into this one already. Now I can plug it into this one and check. 3 times 8 is 24. Negative 4 times negative 1 is 4. Negative 24 plus 4 is 28. I just checked mine. I know I got it right. Okay. Go ahead and pause the video and try these two on your own to see how you did. Okay, so let's see how you did. Let me open up my answer key really quickly so that if you got them right, you can fast forward through my video and say, oh, I don't have to watch that part. I got it right, but I don't have my answer key open, so give me a second. I know that's weird to do in a video, but hey. All right, the number 3 is 3 comma negative 8 in parentheses. And number 4 is the ordered pair, 5 comma 10 in parentheses. If you got those, you can fast forward through this part. If you didn't, let's see what happened. All right, the second equation solves for x, so this is what x is equal to, so I can replace the x with that. So I have 2 times 2y plus 19 plus y equals negative 2. I'm going to distribute my 2 to my 2y and to my 19. So now I have 4y plus 38 plus y equals negative 2. I can combine like terms. There's a 4y and a y. That's 5y plus 38 equals negative 2. Subtract 38 from both sides. That's 5y is equal to negative 40. And then divide by 5. And that's where my y is negative 8 came from. I'm going to start to write my answer by making sure I put the negative 8 in the y spot. All right, now I'm going to solve for x. X equals 2 times y, which was negative 8, plus 19. X is equal to negative 16 plus 19, so x is 3. And there's my answer. Once again, I can check my answer in the first equation. 2 times 3 is 6. 6 plus a negative 8 is negative 2. All right, next one here, the first equation is solved for y. This is the same thing as y. So I can plug this in for y. I have 8x plus 2 times 3x minus 5 is equal to 60. Distribute your 2. It's a positive 2. I have 8x plus 6x minus 10 equals 60. Combine like terms. 8x and 6x is 14x. Minus 10 equals 60. Add 10 to both sides. 14x equals 70. And then divide both sides by 14. So I get x is 5. I'll start to write my answer. That's the x value, so 5 comma. All right, let's get the y value. Can go back to either equation. I'm going to use this one right here because it's already solved for y. Y equals 3 times 5 minus 5. Y equals 15 minus 5, which is 10. Once again, if you want to check your answer, I'll check it in this one. 8 times 5 is 40. 2 times 10 is 20. 40 plus 20 is 60. All right, so now it says, depending on the situation, sometimes there's actually a better method to use than substitution when solving a system of equations. We have seen that we can solve a system using graphing and substitution, but now we're going to learn our third and final method in this class, which is elimination. So elimination is exactly what someone would think it is. It's getting rid of something. You have two variables and you'd be getting rid of one of the variables so that you can solve for the other one. So here's the process. You're going to write the system so that like terms are aligned. We're going to already have them aligned for you, so that's not going to be an issue. What you need to do is you need to make sure that one variable in your system has the coefficients that only differ by a sign. What that means is that you need to see a 2x and a negative 2x, or a negative 5y and a positive 5y, or an 8x and a negative 8x, or a 17y and a negative 17y. You need to see those coefficients that are opposites of each other. If you see that, you combine the two equations, which is adding. This will eliminate one of the variables because those will the 17x and the negative 17x will cancel out. What you're going to do is you're going to solve the new equation for the remaining variable, and then you're going to substitute that back into one of the originals. Doesn't matter which one. Write your solution as an ordered pair when you're done. Okay, so the only problem that will really hit is what if there is no 17x and a negative 17x? What if there's two things that don't cancel out? Okay, so we'll start with this one here. So what I want to do is I want to look at it. I want to say if I combine these right now, will anything cancel? And the answer is yes. What's going to cancel? Hold on, let me change this right here. What's going to cancel? If I add these right now, the 2y and negative 2y. So what I'm going to do is I'm going to put a line underneath it. And I'm going to say 2y and negative 2y cancel. And now I can combine the rest of these. So negative 3x and 5x is 2x equals. And then negative 6 and 18 is 12. And now you just have to solve that. Divide both sides by 2, and I get x is 6. So now I have the x value of my ordered pair. Now I need the y value. I can go back to either original, okay? And I can substitute that x value back in. I'm just going to do the first one because the first one and the second one don't look much different to me as far as difficulty level goes. All right, so I have negative 3 times x, which I already found is 6, plus 2y is equal to negative 6. So that's negative 18 plus 2y is equal to negative 6. I'm going to add 18 to both sides. That's 2y is equal to 12. And then divide by 2, and I get y is equal to 6. So now I know my answer is the ordered pair 6, 6. Now once again, if I want to check my answer, I plugged it into this one, so I can plug it into this one now and make sure that I get 18. 5 times 6 is 30. 2 times 6 is 12. 30 minus 12 is 18, so that is my answer. All right, let's look at this one. If I combine them right now, Will anything cancel out or eliminate? Yes, the x's will. So this one's ready to go also. 2y and 6y is 8y equals 9 and negative 1 is 8. So notice I'm combining them. I'm saying this and this is. Okay, I'm not subtracting. I'm not doing 9 minus a negative 1. I'm not doing 2y minus 6y. I'm saying what's 2y and 6y combined. Divide both sides by 8, and I get y equals 1. So I'm going to start to write my answer with the y value being 1. All right, now I'm going to find the x value. So I'm going to say x plus 2 times y, which was 1, is equal to 9. X plus 2 is equal to 9. Subtract 2, and I get x is 7. So my answer is 7, 1. I could always check it into this one because I plugged it into this one. I'll get negative 7 if I plug it in here, and then plus 6, which is negative 1. So it is correct. All right, so now let's look at this next one here. If I combine them right now, will anything cancel out? Will anything be eliminated? The answer is no. So what I have to do is I have to manipulate one or both of the equations so that this will happen. So I'm going to look at my x's, and I'm going to say this is a 2x and this is an x. I want it to be the same coefficient. So can I get them to be the same coefficient? Or I want them to be opposites. So can I get it to be a 2x and a negative 2x? I can. What would I have to do? I would have to multiply my second equation by negative 2. Now, if I do choose to do that, I have to multiply the entire equation by negative 2. I also want you to realize is that maybe you looked at your y's first and said, I want them to cancel. Well, if I multiply that by negative 3, my y's will cancel. So you also could have multiplied by negative 3 instead, okay? You'll get the same answer no matter what, unless you make an algebra mistake. It doesn't matter which one you do. So I'm going to stick with the original, multiplying the second equation by negative 2. So the first equation is going to stay the same. I'm just going to recopy it down. And my second equation, I'm going to make sure I distribute the negative 2 to everything. So that's negative 2x minus 2y equals negative 14. Now you're going to pretend that this is your original. If I combine these will cancel. 3y and negative 2y is y. 19 and negative 14 is 5. So y is 5. Now I need x, so I can go back to either original. This one actually looks easier to work with, so I'm going to do that instead. X plus y, which was 5, equals 7, so x is 2. I can check it in the other one just to make sure. If I plug in 2 here, I get 4. If I plug in 5 here, I get 15. 4 plus 15 is 19. That's right. All right, let's try another one. All right, if I look at my x's, I have a 3x and a 2x. So I can say I can't get the 3 to be a 2 and I can't get the 2 to be a 3, but I can get them both to be a 6x. So I can make one of them a 6x and the other one a negative 6x. So I could do that, okay? But let's check my y's before I do that, okay? So I look at my y's and have them a 4 and a 3. I can't get the 4 to be a 3 and I can't get the 3 to be a 4, but I can get them both to be 12. I can get one of them to be negative 12 and one of them to be positive 12y. Now, which one am I going to do? It doesn't matter. But I choose the y's. Why do I choose the y's? Because one's negative and one's positive already. So that's already doing some of the work for me. So I'm going to get both of my y's, one to be 12y and one to be negative 12y. So I'll multiply this one by 3. That'll give me a negative 12y. And I'll multiply this by 4, and that'll give me a positive 12y. All right, so let's write our new equation. Distribute your 3. I got 9x minus 12y equals 15. Distribute your 4. 8x plus 12y equals negative 32. Now I can combine these. The 12y and the negative 12y cancel. I have 17x equals negative 17, and then divide both sides by 17, and I get x is negative 1. So I have my x value is negative 1. Now I just need my y value. It doesn't matter which y value or which equation I use. I'm going to use the first one because they look equally, they look pretty much the same to me as far as like difficulty level goes. All right, so I'm going to do 3 times x, which I already got as -1, minus 4y equals 5. So that's -3 minus 4y equals 5. I'm going to add 3 to both sides. -4y equals 8. And then divide by -4, I get y equals -2. So -1, -2. Now, I could also check it into this equation because I didn't use that one. 2 times -1 is -2. 3 times -2 is -6. That is -8. All right, I got 100% on it. Great. Okay, let's look at this one. So I look at my x's. They won't cancel out. My y's won't either. So I say, okay, what can I do to my x's to get them to cancel out? So I say, okay, the bottom one's a 2x. I can make the top one a -2x. And that's only having to multiply one of them by one thing. So I'm going to do that because that just sounds easy. Don't forget to distribute your -2 through all of them. Now the second equation is staying exactly the same. And so instead of writing it to the right, I'm going to write this equation where I distribute right underneath this one. So I have -2x minus 4y equals -16. And then I'm going to, instead of recopying this one down, I'm just going to use it right there. All right, let's look to see what happens here. So 2x and -2x cancel, but 4 and -4y also cancel. So right now I have nothing on this side. 16 and a -16, I have nothing on this side also. So everything canceled out. All my x's, all my y's, all my constants, everything canceled. If everything canceled, that means they're the exact same line. If they're the exact same line, remember what that looks like. How many times or where do they intersect? They intersect everywhere. So if I ask you to write down the solutions, it's every point on the line. Therefore, there are infinitely many solutions. All right, let's try another one here. So I have my 6x and a 2x here, and I say, okay, I can get a 2x to be a 6x. So how can I get a 2x to be a 6x? I can multiply it by 3. That'll give me 6x, and then they'll cancel. So I'm going to rewrite the first equation down because it's not right underneath it. So I'm going to have -6x minus 6y equals 8. And then for my second equation, I'm going to distribute the 3 here. I have 6x plus 6y equals 30. And now I'll combine these. These cancel, the x's, the 6x and -6x. The -6y and +6y cancel. I have 0 over here equals, but on my right-hand side, I have 38. So 0 equals 38 is not true, okay? But I can't solve for x and I can't solve for y. So what happened here is my x's and y's canceled out, but I was left with a constant. What does that mean? That means that these two lines had the same slope. It's just that they weren't the exact same line. They had different y-intercepts. So if they have the same slope and different y-intercepts, where do they intersect? They never do. They're parallel lines. So there's no solution to this. So let's recap those last two here. How do I know the difference between infinitely many solutions and no solution? So let's go back to this right here. Here I got 0 equals 38. Does that make any sense? No, it makes no sense. 0 is not equal to 38. It makes no sense. Therefore, there's no solution. Here I got 0 equals 0. Does that make sense? Yeah, that makes sense, but everything canceled out. That's the exact same line, infinitely many solutions. Okay, last two, solve each using any method you like. You can go ahead and pause the video and try those on your own. All right, I'm going to tell you the solutions right now in case you got them so you can get started on the homework. 1 is 10, 3 in parentheses, and 2 is -2, 3 in parentheses. If you got that, you're done for today. If not, let's see how you get it. So I have to choose whether to use substitution or elimination here. I'm going to use substitution because I can see that x is already solved for. So I'm going to take this and substitute it in for x. So now I have 2 times 3y plus 1 plus y equals 23. I'm going to distribute. I have 6y plus 2 plus y equals 23. I have like terms that I need to combine. 7y plus 2 equals 23. Subtract 2. 7y equals 21. And divide by 7. So I get y is 3. Now I only have the y value of my ordered pair so far. I still need the x value. So to get my x value, I can go back to either equation. I'm going to go back to this one. X equals 3 times 3 plus 1. That's 9 plus 1. X is 10. And there's my answer. I can check it in the other one. 2 times 10 is 20 plus 3 is 23. All right, here's my next one. Should I use substitution? No, because there's no x equals or y equals. So instead, I'm going to use elimination. So I'm going to look to see if any of my variables eliminate right now. 3x and 2x, sorry, 3x and negative 2x, will they eliminate? No. Can I get a 3 to be a 2 or a 2 to be a 3? No. But I do know I can get one of them to be a 6x and the other one a negative 6x. Let's look at y's before we do that. I have a negative 4 and a negative 5. I can't get a negative 5 to be a 4. I can't get a negative 4 to be a 5. But I can get them both to be 20s. So I can make one 20 and y and the other one negative 20y. But what I notice about this is these are both negatives. This is already a positive and a negative. So I'm going to do that because it's just easier for me. All right, so I'm going to get both of my x's to be 6's, a 6x and a negative 6x. I'll make this be my positive 6x, so I'll multiply by 2. I'll make this be my negative 6x, so I'll multiply by 3. All right, so I have 6x minus 8y is equal to negative 36. Distribute your 3, negative 6x minus 15y is equal to negative 33. Now I can combine these. These cancel. That's negative 23y is equal to negative 69. Divide by negative 23. Oops. And I get y is equal to 3. So now I know that 3 is the y value of my ordered pair. Let's get the x value. I'm going to use the first equation because they look equally difficult. I'm going to do 3x minus 4 times y, which I got as 3, is equal to negative 18. So I have 3x minus 12 is equal to negative 18. I'm going to add 12 to both sides. I have 3x is equal to negative 6. And then I'm going to divide both sides by 3, getting x equals negative 2. Once again, I can check my solution in the one that I didn't do yet. If I plug in a negative 2 right here, I get 4. If I plug in a 3 right here, I get negative 15, which is negative 11. So I just graded it, and I know I got 100%. All right, go ahead and re-rate yourself.